Hi there, everyone. I'm here with Vladan Jevremovic and Jemmali of iBwave Solutions. We're going to be talking a little bit about radio frequency design as it relates to digital twins, specifically as it relates to RF design and indoor networks. And Ali, I'm going to ask just to kick it off. Digital twins, I've worked in industries where we've had digital twins in the medical industry of someone's medical history or whatever. What is the context of digital twins when we're talking about it as it relates to radio frequency design, specifically with indoor wireless networks?
Yeah. So, as you mentioned, the digital twin is really a general concept. We can find it everywhere. So let's start really by defining what it is digital twin concept in general. So it is actually a digital replica and a virtual representation serving as a digital counterpart of any physical system and its dynamics. So now when it comes to RF indoor networks, a digital twin is a digital replica and a virtual representation serving as a digital counterpart of the physical RF indoor networks and its dynamics. In other words, RF indoor network digital twin is exactly a copy of your physical RF indoor networks, including accurate 3D modeling and high fidelity simulations and emulations of your RF environments in terms of signal coverage, quality performance, and you can actually visualize it as two entities interconnected with two wavelengths where the physical RF indoor networks can actually send some real data to the digital twin. And this data can be actually processed and treated to simulate and emulate the performance of your digital twin or create some models of your physical network. And intelligently, you can optimize and enhance the performance of your physical networks with the help of this link back from the physical to the physical network from your digital twin. So this is how we can define the digital twin concept in the context of RF indoor networks. Yeah.
Makes sense. So it's essentially a copy, a model that exists in digital space. And yeah, speak to me a little bit more about that. It's a copy, but it's kind of a live copy. What's the most important feature of that digital twin relationship with the physical space and the digital representation?
Yeah, actually, if you look at it, you can really see it as a high fidelity simulation. But the most important feature when it comes to digital twin are really the two-way links between the real physical indoor networks and its digital replica and virtual representation. The link from your physical indoor networks to the virtual representation or your digital twin will actually help running simulation and emulation and evaluation of the digital twin replica with real data and real KPIs that you get from your physical networks. And the other link, which is the link from the digital twin replica of the indoor networks, can also help you optimize the deployment parameters of your physical indoor networks. Like, for example, you can think of power adjustment and resource allocations that you can use in your real physical network. So these types of feedback links between the two can really help improve a lot of parameters like energy efficiency, improve capacity of your system, and improve the load balancing of your physical networks. So this is really the main features of digital twins when compared to simply simulation or emulation, where you don't have any link between your physical and digital counterpart, and you are just making simulation without having any connection with your real network. But for digital twin, you really need to have these links to get the benefit of digital twins.
Yeah, so it's kind of like a live connection between the digital representation and the real world. So if you're wanting to model out, oh, what if I changed, the floor of the manufacturing facility and I moved in this specific engineering setup, how would the antennas need to move in order to accommodate for new physical? So you can kind of have like duplicate versions of your facility and then model out what it would be if you change things around in real time.
Exactly. Yes, you got it.
Yeah, that makes sense. So how does the data synchronization work between the real network and its digital twin? Like how often does the network data, need to be synchronized for it to accurately represent the scenario that the twin in real life is showing versus the digital?
Yeah, it is a good question. Thank you, John. So it really depends on the application and use case of your digital twin. So as I mentioned before, so you can use this digital twin for different use case and for different parameters. So for example, for the use case of using the digital twin for network optimization and problems. So the frequency or the link between these two could be every, let's say, 100 millisecond or 1 sec between 100 millisecond and one second, because your goal here is really to optimize the network and the operation of your network. So you need really much faster or more frequency of having this data between your two entities. But however, let's say for near real-time analytics, let's say you want to predict the maintenance of your system, you want to evaluate the load balancing. So in this case, the frequency of synchronization between the two could be higher than the first one, let's say in the order of seconds or two, between seconds to minutes, because you really don't need this frequently data to predict the maintenance or to optimize the load balancing of your systems. So this one can get from second to minutes. And there is also a third option that we can consider, and it can be longer as a frequency when you get this type of data. It could be for capacity planning and long-term optimization of your network. In this case, you may need a frequency about daily or weeks. Even it can go to weeks to get this type of data so that you can optimize your capacity planning or long-term optimization, or even it could be also for maintenance or to maintain your physical network. So it really depends on the use case of the digital twin, where or how you want to use it. So yeah, I think this yeah.
And I can imagine that's a lot of data that it can require, depending on the situation, to keep the fidelity of that connection accurate and representing the digital space and physical space accurately. So obviously, there's the hardware elements. There's the antennas, the cables, all of those elements that are relevant to the digital twin. Are there other digital twins that impact the radio frequency design and how that's planned and maintained?
Yeah, yeah. I think in addition, of course, to what you have mentioned, John, there is really a very important and significant component of digital twin, specifically for indoor network, is really the 3D building of your physical environment. So having an accurate 3D building with very detailed information about the radio wave propagation characteristics of the building's material is really a must for designing digital twin indoor networks. And in this context, to achieve this type of accuracy and of detail, So there is the new, I would say, standard way really to design this network is really the building information modeling, which is a BIM, known in the BIM in the industry. And it is really a key technology and methodology to actually create and design your digital twin indoor networks, and how it is different from the traditional way of 3D modeling, where we use really CAD file to model the environment. In this beam technology, you really may have a lot of detailed information to do that. Not only the physical location, the height, the width of all your materials that is making your 3D building, you will need also to have the characteristics of all these materials. So, in propagation, we need to predict using the deterministic ray tracing algorithm for the prediction of coverage. We really need all type of information like the permittivity of your material, the conductivity of your material, the thickness of your material. So all this type of information can be really used using this concept and this technology of beam modeling. And it is really a mandatory to have this type of modeling in order to really have a good representation of your physical network by knowing all these parameters and using these parameters to make accurate prediction for your indoor system. So this is really what I think it is the future beside the RF equipment and a component of your network environment. Yes.
Makes sense.
Mhm.
So, Vladan, let's talk a little about floor plans. As it relates to digital twins, aren't floor plans good enough for letting us know where walls or other obstacles are? Once the building has been designed and built, uh, those things don't move around. So, we talked a little bit about BIM as well, but what's the relevance of floor plans and layouts to the digital twin scenario?
Yeah, so floor plans and layouts are critical because the walls have to be in the right place and have to have the correct material assigned to them in order for us to do an accurate RF prediction. And misidentification of a wall material or wrong positioning of the wall will yield an incorrect RF coverage map. And when a technician is out there doing the site survey, having CAD files of the floor plan helps a lot because it allows a good RF planning tool to automatically make a 3D render of a floor plan. And an experienced technician can correctly guess the material most of the time. Having digital twin is even better because a wall digital twin will also have information about wall thickness, about wall permittivity and permeability. And these three pieces of information can tell us the correct amount in dB for wall penetration loss and wall reflection loss at any frequency. However, over time, floor plans are updated, but CAD files may or may not, and digital twins may or may not be updated. An engineer or technician can spot a missing wall when on a site survey, but sometimes they get overwhelmed and they may miss that. So that poses a problem.
So, yeah, what's the penalty for that scenario when you're talking about a digital twin and let's say the wall gets moved, or like in a manufacturing facility, the floor gets changed. When you have the wrong type of material associated, or a material that's missing or gets changed in a significant way, what kind of KPIs are we looking for, and how are those affected by those significant elements?
Well, I prepared an example. And this is an example of an RF survey when the manager forgot to update a floor plan. And you will see I circled it. We have data points that are very close to each other. And on the floor plan, It doesn't seem that there is anything in between them. But you see that to the left, the RF survey is hot, and to the right, it drops significantly. It drops from red to green, and it is, about 10 dB difference there. So why is that? Well, they obviously missed at least one, if not a couple of walls. And that is what can happen when you did have a remodeling and then you forgot to update your CAD file. And, when we do a survey, oftentimes, we do not pay attention of what is being recorded. What we do want to know is when we do a spot check, when we are below the antenna, and then we calculate what is the signal level about 1, 2, or 3 meters from antenna, when we are right next to the antenna or below antenna. And if that number makes sense, then off we go. We usually do not even check, how much it is at any point. We just are focused on completing RF survey. And then we get back to the office and we see this, and that obviously means that there was a wall in there, and we thought that it was in the CAD file, but it was not. So we have to go back to figure out what wall material it was, so we can go and import that into the floor plan. So now, how does that show up in our analysis of prediction versus measured data? Well, there is another example there. So here, what you see is that we have absolute mean error that is greater than 10 and standard deviation greater than 10. Typically, if everything is correctly modeled in our tool, you will see absolute mean error being in less than 6 dB, about 90% of the time, and standard deviation being less than 6 dB, about 90% of the time. Surely you would not see standard deviation of 10 or absolute mean error of 10. When standard deviation is very high, that means that you are either missing a wall or you mischaracterize the wall. That is your indication that something is wrong. You either make a wrong guess or there is a missing wall. So that is how you would see it in this analysis, even if you are not able to see it on the RF survey plot.
Makes sense. So with the digital twin, what you're saying is that wall placement, wall material, identifying the wall, things like that are very important in that process, and incredibly important to the network design. But unfortunately, we're still mostly relying on outdated CAD files, or something in the building changes and we are not aware of it, and then we have to look at the data and look at how that's changing the KPIs for the implementation. What needs to happen to change that problem? If you've got a difference between the physical environment and the CAD files, and you can see, changes in your KPIs as a result, what does the future look like as it relates to digital twin management?
So there are two approaches. For RF technicians, they go on a site survey. What would be incredibly helpful is to have a LiDAR of a similar device that is capable of scanning a whole floor, and while technician is walking around and making a 3D render of the floor plan, once the whole floor has been walked. What we do have now is something similar to it, but it is just not granular enough. We have played around those LiDAR devices, and they are probably around 3, 4, 5 years away from getting something that would be useful in commercial applications. It's good enough if I want to scan my room, but if I want to go on and scan the 5,000 square foot, floor plan, then that's a different matter, right? So something like that would be incredibly useful for a technician, to identify where the walls are. Well, still, you would not be able to guess 100% of the time the materials of those walls, but at least we know where the obstacles are. And the second one is related to what Ali was saying, periodically updating a digital twin. So obviously, those the fact that rearranging the floors or walls or what have you, when one tenant leaves and the other one moves in. That doesn't really happen all that often, but it does happen. So what would be great is if we could have some kind of a periodical scanning of those floor plans after hours. For example, if we can have a drone that could go around the office, randomly, like similarly, like you have those things that clean your house, right? They go randomly around. Well, something like that through the office, maybe once a month or once every couple of months, that would be like flying like 3 feet off the floor or 4 feet and scanning, the surroundings, and then basically comparing what they scanned with the existing digital twin floor plan or a CAD file floor plan. And if there is something that has changed, they can point out and then use AI technology to identify what could be a possible material for the wall that has been removed or placed in or put in place. So that would help a lot automate all this and resolve a problem of floor plans not being regularly updated. So think of this, regular scanning of the office environment, something like not really quite like cleaning, because cleaning happens, every day, but maybe once a month or once every 2 or 3 months that goes around and just confirms, what obstacles we have, and if those obstacles are where they should be, and if the materials related to the obstacles are what we think they should be.
Very interesting. Yeah, I could imagine. Almost feel like you've come up with a new business concept here. You're, a company that's got the vacuum cleaner robots that are cleaning the office. You just attach a scanner to the top of that device and have it also scan the physical environment. Might not be a use case that's coming up anytime super soon, but I could see that being, scenarios like that could
it is
keep
possible.
things
Yeah,
updated. Yeah,
it is possible. Yeah.
interesting. Well, thanks so much. This has been a great discussion to better understand digital twins and how those things are relevant to the design process, and even thinking about the future of potentially a drone, or like you said, if there's some sort of device that's going through the office on a regular basis, it could also be scanning for changes in the building setup in order to keep things accurate. I do think that kind of thing will probably be happening in the future. And we'll keep an eye on how that develops, and I'm sure that'll make the network even more relevant as it's more accurate to what's physically represented in the space on a day-to-day basis.
Yes.
Well, have a great day. It's been great talking to you both, and I really enjoyed it.
Thank you, John, for having us. It was a pleasure.